Good morning. This is Dr. David A. Paget. Uh, and this is our third day, well, second day actually, third class. And this is the third class this week where we at the Geographic Information Sciences Lab at Tennessee State University are observing Earth Week. And as usual, we do this every year. Our students be the main attraction today, and they will be presenting their data from our GLOBE program data collection. So what happened was for those of you who are joining us via Zoom, few weeks ago, well, not a few weeks ago, I can tell you the exact date, on March the 30th, our students collected data on TSU's campus using the Globe Atmosphere Protocol procedure. And then we had groups of students take the data and translate that data into data visualizations using two different platforms. Several groups of students that you'll see in a few moments use ArcGIS online, and at our pre-service teacher used the Globe data visualization system. So the first students that you will see completed this assignment. And so they were required to have an ArcGIS online account, set that up, and then they had to take the data from the that was entered into the Globe into Excel spreadsheets, as you can see, and then those data were entered into ArcGIS online or uploaded to ArcGIS online. So the full procedure, as you can see, was to take raw data from the Globe data collection sheets, as you'll see here in a moment. So the Globe data collection sheets were made available to the students and were scanned, well, actually photographed, and then this raw data was then translated in the GIS format. So the students picked up a very important skill in taking raw data that wasn't necessarily in geographic format and then creating data visualizations using ArcGIS online. So without any further delay, I'm going to bring the first group up, group one. And so the students will introduce themselves and name, major, where you're from. And then I will walk students through the process of we'll see. This is the first time most of these students have used GIS, so there's going to be some teachable moments here today, and so we will walk through whatever speed bumps the students run into today, and there will be definite speed bumps today. So the first thing that we're going to do is get started here momentarily. We have plenty of time today, so I will pause the recording for a moment and grab something from my office. Okay, so our first group is going to come up front. And this This is going to be interesting. We're gonna try to do some forensics here today. We'll see how this works out. And so, first group, one, forward. The camera's up there. So group one, Barn, Ford, Lee, Harper, Woods. Side. So just introduce yourself, name, major, classification, where you're from. Somebody's gonna have to be pilot. So introduce yourselves and then you get started. Cameras over there. Okay.
My name is Tyler Soares. I'm a freshman at TSU, and my major is mechanical engineering.
My name is David Barnes, freshman at TSU, major is mechanical engineering.
I am Kylan Harper, a freshman civil engineering major from Smyrna, Georgia.
Okay, so I think I have your map up already. You can get to it. So this tab is up in the top. It's the third, not that. The next tab, next tab.
I can't see it, bro.
Yeah, just kind of, yeah, the zoom is kind of a pain in the neck. Yeah, let me zoom. Sometimes you have to comment. All right, I think that, yeah, I know that's your map. Okay, so
We're supposed to have two spots on the map, right?
yes.
Can we do my map?
Oh, there's another map?
I have one.
Okay, let me get to your map.
It's I have two.
So we're gonna pause and record here just for a moment. Okay, so once again, we're going to have group one present their data. So let's first take a look at what we have here. Okay, so let's see. This is fixable. Okay, so if you notice your data, so the first thing we're going to do is try to fix our symbols. So if you notice, notice that your current temperature is how many degrees? Your maximum current temperature is how many degrees Celsius?
26.3. Which one?
No, current temperature.
No, current 19.
Okay, and then your maximum surface temperature is how many degrees Celsius?
26.3.
Looking at this. It appeared, should your maximum surface temperature radius be the same radius, or it looks like it might even be smaller than the 19 degrees Celsius radius?
No, I shouldn't.
Yeah, okay, so let's go to, let me see, then let's look at the minimums. See, the minimum current temperature is 16 degrees Celsius. So we're gonna see. All right, so let's just go to content. We'll have to try to we'll work around this a little bit. Oh, well, the first thing, whoa, wow. Go back to legend. Okay, okay, go back to, go scroll up to legend. Okay, get that. Okay, go to content. don't understand what's going on there, but let's just stay there. Go to content, go to change style. No. The next, no, one more. Yeah, right. One more to the right,
Right.
Yeah. Change style, go to options.
Where are options?
Use past that.
First.
Options. Scroll, let me see, let's see. No, go to, okay, right there. Scroll down. Let's make the max surface temperature pixels at 75. Make that 75. So we only go from 23 to 26. So let's make the minimum 50. Let's make the minimum 50. Let's see what that looks like. Oh, I'm gonna make the minimum 50. Hit OK. All right. Wait. Go back again. I don't think it took. Yeah, hit option. Make the minimum 25. Something that's what's going on here. Okay, go back again. Options, go down. Doesn't make any sense. Oh, okay, I see. Go scroll up again. Okay, see that little blue half circle? Slide that up to the top. No, wait. No, don't do that. Slide it back down. What's going on here? Okay. What are symbols? What the outline? No, it's not that. Just hit OK. Can't. Oh, hit invert. There we go. Okay, now new something. Okay, now hit. See, we got from 25 to 75. That should work. Hit OK. All right, hit done. Okay, now we're getting somewhere. Go to the next layer.
Right here.
Yeah. Change style. Okay, so we had 19. Go to options. Okay, that one's fine. Okay, scroll down. And see, the max is 50. Let's make that minimum. What was the minimum for the other? Make the minimum 20. Wait, make the minimum 15. All right, hit OK. Let's see how that looks. Get done. Go back to the legend. All right, so okay, go back. I'm being real nitpicky now, but that's just how it is. Go back to content. Go to that. Go to change. No, wait. You go to change style. Wait, no, hit those three little dots. Maybe we can change the transparency there. Yeah, go to transparency. Change that transparency to like 50%. Yeah, there we go. Okay, now just you can close that. All right, so now we can see through. All right, bring the legend back up. Okay. So let's see. So now, yeah, current temperature max is definitely smaller than our surface temperature max. Let's go to the minimums. 23. Yeah, that's it. That's what we want. Okay, so now we're gonna get into some data analysis. Notice anything different about the two sites in terms of their current temperature versus surface temperature?
Current temperature of the site we did near the grass, near the Creek place. Current temperature is a little bit lower. No, it's a lot higher than the current temperature of this site right here.
Because the trees, right? Trees, shade.
Well, this image. We went out there on March 30th. Was a leaf out like this? Was there, were there leaves on the trees, like what you see in this image when we were out there?
No,
No, it wasn't.
No, evergreen trees, absolutely not. There weren't leaves on the trees, so. Should the. So let's examine this. So let's just, well, let's cheat. Let's just click right on the Old Courtyard Northwest site. See, so there we have a.
Wait, this is the corner of the site.
Yeah, that's northwest corner side. And let's see, we have concrete land cover. And the average surface temperature was about 10 degrees Celsius higher than the current temperature, which is reflected in the symbology, clearly reflected. So now let's go to the courtyard lawn site. And still, something is still not right here. Okay, so let's see, the current temperature is, all right, let's go back to content. I got to figure out what's going on here. So let's see, current temperature. You go to that second layer. Second layer, yeah, that.
You talking about imagery or?
No. Yeah, okay. Go to change style, go to options. Okay, let's see. So scroll down. So let's see, so we had max is 75, max of 50, but the max current temperature. Okay, that has to be less than our minimum. What was our minimum on the other? 25. Make that max 20. That's where that minimum. All right. All right. Now we're hit okay. That should make this look right. Hit done. Let's see now. Okay. Go to legend. Okay. Scroll down. Yes. So we have. Click on that second dot, the one on the grass. What's that? Oh, so that's 19. Current, well, that's very interesting. Current temperature is 19. And then the surface temperature is 23.7. Close that box. It's 10-degree difference. I mean, this is not exactly, it'll do for now. Probably it would be better if we go back to content. Let's try something here. Go to that second layer. Change style. Go to options, symbols. Change that symbol fill. Go to fill. Change it to like a red. Let's see. Hit OK. That's a little better. Hit OK. And then hit done. Yeah, okay. Now we can kind of see a contrast between the colors. Perfect. So now we can see a contrast between the colors. Go back to legend. So now we see that at both sites, the surface temperature is higher than the current temperature. But what do you notice in terms of the difference between the temperatures of the surface versus the current temperature in northwest corner versus on the grass?
So the surface temperature in the grass and the current surface temperature are pretty similar. Like, if not the same, but they're off a little bit, but they're pretty similar. But
Yeah, it's pretty close.
On the site, when we use concrete, it's a major difference.
Okay, and click on either one of the points. I don't know. Let's see. What was our scroll down? So our cloud cover was only, we hardly had any, it really wasn't even 10%. Right, cloud cover was basically none, so clear sky. So both sites were pretty much in direct sunlight. There was, scroll down, we didn't get the tree, we need on trees. So you can close that box. So we can clearly see that even with the same amount of incoming solar radiation, so remember, is the Earth's atmosphere warmed by shortwave radiation, longwave radiation? It's longwave radiation. Shortwave radiation comes in from the sun, that's ultraviolet. It's absorbed by the Earth, and it's released as long-wave radiation. And that long-wave radiation energy is absorbed by greenhouse gases such as carbon dioxide, methane, and water vapor, which is a gas. And so we clearly see with the map symbology the effect of that concrete, and versus also the effect of the grass. So yeah, I guess this would be an easy question. So, well, I guess maybe this might not be an easy question. So in terms of urban design, maybe I should ask Harper this. If we were trying to mitigate the effect of the concrete in elevating the temperatures here in this area, and we were to implement a certain kind of urban design, what would we call that? Strategy of using, well, I'll maybe that was too vague. What do we call a strategy of using natural materials versus human-made materials in urban design? Okay, the first, it's two words. The first word is green.
Greenhouse.
Green infrastructure, green infrastructure design. And so I showed you all the
That building, right?
yeah, the Music City Center, our new convention center, and the whole roof is green. And so you notice that whole roof is grass, excuse me. So think about the energy savings that occur in that building when you have grass there instead of what typically would probably be a black asphalt roof. Think about it, and you can actually calculate the energy savings that would occur using green infrastructure design versus the traditional building design where you use asphalt or concrete and who knows what on that roof. Let's see. So now what's interesting is who knows when this aerial photograph was taken, but clearly it was when we have almost full leaf out on campus during the summer, or maybe even during the fall.
I just changed the base map,
What's that?
but the base map is different.
Yeah, but I mean, it's not, you're not gonna have like a real time.
Oh, it's not really.
Yeah, oh, no. But if we were outside and the leaf out was, as you see here, how might that affect our data? How might that affect the outcome?
The surface temperature would probably go down, like the blue circle for the corner would probably.
Yeah, exactly. When we do this same exercise in the fall of the year, it might, the trees have a significant cooling effect, and we almost end up with the exact same outcome for the grass and trees. Or sometimes we'll see that the spot on the grass, depending upon what time of day, will have a higher ambient and surface temperature than in the shade. And so what is happening now in urban landscape design is developers are leaving trees in place as an energy saving strategy. Because what happens is, of course, when you have trees around, significantly cools off community infrastructure, and it's an energy saving in the summer, significantly cools it off. But it used to be in the olden, I mean, sometimes they still do what's called leveling, which means the contractor would go in and cut down every tree in sight, leave no trees, and then start building homes. Anyway, so good job, group one. This is a good job on the map. So give group one a hand here. Good job, good job. So we're off to a good start. Just had a little, just had to adjust the symbols, but yeah, they got everything. Oh, we have one here. So they have everything pretty much, you know, the points are there, just had to adjust the symbols. And so that's what's most important. That I in geographic information systems is the most important part of GIS. Okay, so let's see, let's bring another group up here. Share for a moment. And so let's bring another group up here. That was a good job by group one. See, we have guests who have dropped in on us today. So you all are on blast, as you young people say. But that's a good thing. Let's see. So our next group is group 2, and group 2 is Bryce, Tidwell, Walker, and Cromwell. So again, these students were assigned the task of taking globe data, global learning and observations benefit the environment data. And so here are the raw materials. They took the globe data that we collected outside, surface temperature and current temperature, and also we did a clouds observation. We converted, the students converted that into ArcGIS online format. And so that is what we're about to see from group 2. Whose map should I use? Or is everybody's map? Let's see, this is hard for, whose map should we use this group? Here. Yeah, they're here. Yeah, we have Price, Tidwell, Walker, and Cromwell. I don't know if they're all here, but well, I'll just pick one. We'll see. It's always an adventure. All right. Yeah, that was a hard act to follow. I wouldn't want to get up after group 1 either. Let's see. Cromwell's got some.
I'll use one. Choose
No. You might have no choice.
You should choose the one that was the earliest. I think that's the best idea.
All right.
Like the earliest turned in.
Does anyone else? Yeah, that was group 1, group 2. So this is not this one. This is error PNG. Let's see, what is this? What we have here? Okay, well, we have a sheet. Oh, did you make this map public yet?
Yeah, it should be public now.
Okay, we'll see. All right, we'll see here. And drum roll. Okay, we have a map. Oh. Yikes. Okay. We might, well, let's do some, we might do a little surgery here. This is what we call a teachable moment. What? Okay, so come on up, introduce group 2. Whoever's here from group 2, come on up, introduce yourselves. Name, major, where you're from. We do have guests now. There are people who are watching us now, so you all are, yes, we have guests. All right, so come on down, group 2. Don't worry, we can We can work this out. Just your name, where you're from, oops, where you're from. Major, name, major, where you're from, classification. Cameras up there. In the back of the room.
My name is Nathan Price. I am a junior mass communications major and I live here in Nashville.
Next.
My name is Grant. I'm a computer science major.
That's Cromwell. Next.
My name is Leroy, and I'm a computer science major.
Oh, what's your last name?
Walker.
So we have. Group 2. Okay, so clearly there are some errors here, but we're all learning here. Let's see. Wow. Okay, so we're going to try to do some forensic surgery on the data here. Okay, wow, okay. Let's see, click on either one of those points. Let's just either who's going to be the pilot. This piece of cake, you guys are computer science major. Piece of cake. Fix this. All right, let's see what's going on here. Whoa. Clearly the error is with latitude and longitude. And let's see. Okay. All right. 86. What in the world? Okay. All right. Let me see how if we can do this. Go to that. Wait, oh, are we still oh, sorry about that. Sharing screen. Yes, can't see anything. Sorry about that. Okay, so now we're sharing the screen again. All right, sorry, guess. Okay, so we have here's the screen. So here's the map that the students created using ArcGIS online data. Using the globe data, using the ArcGIS GIS online platform. And so we're going to demonstrate how to fix errors in database in real time. Okay, so let's see, where should we even start here? So, okay, I'm gonna have to come up here and assist, walk you all through the surgery. But these guys are computer science majors, so this should be a piece of cake. Nothing for them to fix. All right, let's go. I'm gonna just stop share just for a moment. And go here. And then go over here. And then let's see, what do we have here? That is. That is. And so we have serious issues here. So let's see. So we have. Let's see what we have here. Price.
Is there a Dropbox for today?
For today?
Yeah,
Did you put something in today's?
I think I might have accidentally put it in today's Dropbox. Because it was assignment number 5.
Save. Oh, yep, there's something in there. No, that it's not, but it's fine. Hey. Is this a different map?
I think so, yes.
Oh, and we have version
But
map
it may not be
2.0.
yeah.
Yikes. This one is. What's going on here?
Latitude off.
And it's, um. The pain is this.
That's just good.
So, yeah, so do you have your spreadsheet?
Yes.
Do you have your laptop? Did any of you guys have a laptop?
Yeah, let me see.
Yeah, okay, we're gonna pause and record here for a moment. And but hang with this guest. We're just we're all learning here. This is what we call a teachable moment. And no need in having a car and driving it and not knowing how to repair it, right? So we're gonna do a quick fix here. Back. So I'm gonna walk these students through how to repair their data sets. So remember, the I in geographic information systems is the most important part. Okay, so the first thing in field A, see that 3 and 4, take those out of there. Just delete those. You might have to hit, is it editable? Can you edit, and this should be able to edit. You can just move, you can just slide that window down somewhere else. Yeah, see the 3 and 4 that's on field, yeah, the 3, 8, yeah, get that out of there, get that out of there. Okay. Yes. Oh. Good looking out. Our guests were like, what's going on? Okay, sorry about that, guests. So what we're doing is we are repairing the attribute data table. Clearly there are errors with latitude and longitude, but we'll see what happens here. We'll see. Okay. So we have the data looks good. The data looks good except for the lat long. Okay, go to Google Maps or go to Google Maps. It's in some kind of way. Yeah, you can open up a new, go to Google Maps. You can just open up a new tab or whatever. Yeah, there you go, right there. That's not it. Go to the other side, maybe just shut down. Yeah, I know when working in Zoom is just such a super pain in the neck. Yeah, just yeah, so now you can get to Google Maps. Okay, and so now let's zoom in on TSU's Tennessee State University's campus. We're in Atlanta, we're in Nashville, okay. All right, keep scrolling until you get to TSU's campus. Now, this is going to be an approximation. Keep scrolling in, keep scrolling in. Zoom in on the old courtyard, that's where we were. Okay. That's here, the whole courtyard. You might want to change the base map to the satellites down in the lower left-hand corner. Change the base map to satellite. Okay, that makes it a little bit easier. So we're going to scroll into the old courtyard, zoom in on the old courtyard, and all right. So the old courtyard northwest corner site kind of get a little bit close, a little bit northern, maybe back a little bit north. Right, yeah, maybe right there. That's close enough. Right click. Boom, there's your lat long. Hopefully the correct lat long. We'll see. So you just click right on the lat long. It's gonna copy it to the clipboard. Yeah, there you go. Copy the clipboard. Okay, go back and let's see. That was the northwest corner. So just make sure the other one. What's the other one? What's the other one? Okay, good, to the northwest corner, so take the lat long there out, just delete that, and delete the longitude too. That, okay, right click, it is paste it in there, boom. Okay, now what you're gonna have to do is, yeah, get that longitude, minus sign. And then put that in the longitude cell. Yeah, there you go, paste that right in there. Boom, go back to your latitude cell. Okay, that's clean. Okay, you might want to hit save on that. Okay, good. Whatever. Okay, now do the same thing for the point on the lawn. Whoa.
So about here,
Just, yeah, a little bit, that's close enough, that's fine, as long as it's on the lawn. Got a guest trying to get in. She didn't. Wasn't too long ago. Shoot. Okay, so you replace a lat long. Okay, now do files, save as. And save it at, oh, it's already a common delimited file. So just go ahead and save it anyway. See, where is it saved? It's gonna be still in download. I'll go to browse. Browse, yeah, and then put it in the Paget folder. Now hit save. Okay, so now let's go back to now. One of you, can you log in? Go back to ArcGIS Online and then when you log in, if you can remember your login, because you have to be logged in to actually do anything. See, where's your? It's yours.
It's,
That's the old one. That's the other one. Where's the one that at least partially correct? Or did we even open it? Where's the other one? Keep going. Thought we pulled up prices. Is that prices? Not source. Who's that? This is no way. Yeah, this is the one. This is the one. All right. So sign in. If you remember your sign in for ArcGIS. So wait. Yeah. Be careful. So you're signed in. Okay, go to content. We'll go to details first. Details again. Click on that center icon. I mean, yeah, that right there. Okay, take the check mark off of those two layers. Okay, now go to add. And it's right at the top, right? It's right up here, right? Add layer from file. Okay, navigate to the Paget folder. And then it should be that first one. See import layer. And oh yeah, that's so pretty, isn't it? Okay, so hit done. Do two things, hit done. Then hit save. No, wait, save. Should be able to save. Save. Lord. All right, don't worry about it. Oh, there it is. Oh, yeah, save it. Save as. Call it group 2. GI 1010. 04. In tags, just call it Let's do ArcGIS online. Okay, that should be enough. Hit save map. Boom. Okay, so see those three little dots? Yeah, right. Click on one of those three little dots. Go to rename. Change the name to let's make it quick. Call it let's call it LFT temperature. And hit OK. Okay, now go to add again. Add layer from file, add that same layer again. I mean the same data table again. And import layer, boom. Okay, give it a second, hit done. Click on those three dots. Rename. Call this one IRT temperature. Infrared thermometer temperature. Okay, go to change style. Right, no. See right under where just cross right there. Yeah, change style. Change the attribute to no, don't add attribute. Okay, change that to average surface temperature, IRT, boom. Give it a second, okay, hit done. Okay, go back to that, change style again. Go to options, scroll down to options, right there, options. Okay, man, span that window. Okay, click on symbols. Yeah, change the fill to a red. Yeah, red, and then change the transparency to like 50%. Yeah, okay, that might work. Okay, hit okay. Okay, boom, done, boom. All right, go to the next layer, the LFT temperature layer, right? Change style. Okay, change, go to options. Whoa, what's going on here? Go back. Go to options again. Oh, wait, I'm sorry. Change that attribute to current temperature, LFT. Give it a second, go to options, change the symbol, change that fill to blue. Blue, yeah, nice blue shade. That should give us a nice contrast, maybe. Hit OK. All right, that's decent contrast. All right, hit OK again. Go to done. Go to that third icon is your legend. All the way to the top. No, that icon. Legend. All right, let's see what we have here. Wow. Okay, so we're almost to the promised land. So clearly we need to make some adjustments. So we've got the current temperature. Okay, click on the old courtyard northwest point. Let's see, scroll down. Scroll up to the data. So for that one, the average surface temperature is 22 degrees Celsius and the current temperature is 20 degrees Celsius. So that one looks like it should look. So we clearly, wait, no, it doesn't. Because
I know on one of them, there was a temperature that was a lot lower, like the infrared temperature was like 19 degrees Celsius. So it kind of changed the average.
yeah, I mean, that's. Okay, so no, but this is right, this is correct, so this blue, yeah, that one's right, so close that one. Then let's look at what's going on with the other one. So the average, okay, so something is wrong, the data's fine. It's just that the symbol is off. So the current temperature. See our average surface, what? Okay, go to the second icon, can
This one
you're
here.
not the second, the middle one, yeah. Show contents, go to the LFT temperature layer. Change style, go to options. Scroll down. All right. This doesn't make any sense at all. But let's see, how can that max be for it anyway? No, go back. So let's take that max, make it, keep the minimum the same. The max is the problem. Make that max maybe 20 pixels. Let's see how that works. Make it 20 pixels and then hit OK. And then hit done. I think that is still, go to legend again. Go to legend, it's still not. Okay, okay, now, wait, still something's off about this still. Okay, go back to the middle icon. We're gonna fix this in 2 more minutes. Go to the infrared thermometer temperature, change style. Okay, make that, scroll down, go to options. Scroll down. Make the minimum pixel size 22. The other one was 20. Let's try the minimum pixel size 25. Let's see how that works. This should do it. Hit OK. Yeah, that's gonna boom. Yeah, that's it. Okay, hit OK, done. Go back to legend. Okay. Hit save, hit save, hit save after all that. I don't want to lose. You know, okay, so now after all that, surgery, good job, gentlemen, good job. Now we can clearly see, and we'll be done with this, that our surface temperature is higher, so the infrared thermometer, long wave radiation temperature is higher in both locations. But do you see anything that you would not necessarily expect? Well, I don't know, maybe. So we have what surface do we have for the northwest corner? What was that surface material?
It was concrete.
It's concrete. And then but the grass, we had what? We expect to have a higher surface temperature, that much higher than the ambient temperature on the grass.
No.
Or is it really that much higher? Let's click on the old courtyard site. No, that's a lawn, that's a lawn. Well, we can start there. So let's see, we have a max of 23 degrees Celsius versus 20 degrees current temperature. Let's go to the old courtyard corner site, max of 22. So really what we're seeing is our selection of how our symbols appear, because there isn't really that much of a difference, is there? But our symbols make it appear as if there's a big difference, but it's really only like 1 degree Celsius difference in terms of the gap between the current temperature and the surface temperature on each site. So really, we would have to adjust our symbols. We're not gonna do it now because they're almost the same. So it could be perhaps that, could be time of day, perhaps we were like out there, let's look at the second observation. First observation was at 10:36 a.m. Let's look at the courtyard lawn. See if there's a significant gap in time. 10:45, 9 minutes. No, that's just very, we have to look at that further. In your analysis, in your answers, did you offer any explanation for this? Those very similar outcomes, even though we had same amount of sunlight, no shade. And these are totally different results than what we got with the first group, right? The first group had like a 10°C gap. Anyway, good job. You can marinate on that. Good job, group. So we just had a few hiccups there, but again, no point in getting a car and not knowing how to fix it, right? Let's see what's in the chat. Chat. Oh. Oh, no, it's, yeah. We wanted to have guests. All right, so that's good job. So on to the next group. We don't have too many. We've got to get Miss Lane up here later on. Can't do this without the pre-service teacher. Let's see. So group 3 is Evans, Tacey, and McDonald. So let's see what we have here. Dropbox. Let's see, we've got. I know what that is. Evans, McDonald, and Tacey. So, well, I guess we're gonna move on. Wake Miss Lane up. She's up. So the next person that'll come up here is the illustrious Miss Lane, who's our pre-service teacher. And so the pre-service teachers did a different assignment. And so here is their assignment, Globe. So the pre-service teachers, engaged in a very important part of the global learning and observation to benefit the environment training. And that was to take the globe data from the globe data sheets and convert it into this form, as you can see Miss Lane did here. And then she used the desktop data entry, entered data from the spreadsheet. So this is a very important part of Globe because this is how the kids' data gets into the Globe observation system or data visualization system, excuse me. Then next, the teacher, Miss Lane, well, all the teachers use the Globe Observer app and enter the data from the second site on the courtyard lawn. And then also when she used the app, she got satellite match, got the date correct there. Yep. Good job, Miss Lane. And then at the end of the day, she wound up with her data on the data visualization system, which we're about to demonstrate right now. So go to the Globe site. I could sign in. I don't think it's necessary, but I'm going to sign in anyway. Still sharing the screen, thank goodness. Okay, Miss Lane, come on up. You're representing our teachers today. You're Miss Lane, right? So introduce name, major, classification.
My name is Denaya. My major is early childhood education. And I'm a
And
freshman.
you're from?
Chicago.
Okay, so Ms. Lane, go to globe data, please. We're gonna pull up your observations. Go to visualize data. You're in the visualization system. Go to enter the visualization system. And do you remember how to pull up your data? Okay. A little bit to the left, to the left. Okay, it's coming back to you now. Okay, what's coming back to you now? See, you young people, your memories, sharp memories here. See, this came right back to. All right, good job. That. Oh, don't forget the contract. It's all the way at the bottom. It's all the way at the end. So we think we just had short contract. Okay, and then of course surface temperature. And then I think that's it. And then we'll go to submit. And of course, now we can change the date. Just change, whoa, yeah, there you go. That was March, yeah, there you go. Now we're gonna zoom in on TSU's campus and we'll see what we got. So this is the data that we collected on March 30th. And let's see, we might see some interesting things here. So Ms. Lane used her own data. And so this is part of the certification process. Okay, right there. Okay, see those three dots in the upper left-hand corner in the pull down menus? Left hand, those three dots, hit that, boom. Go to choose base map. Change that to satellite. And okay, there we go. That's a little better. So zoom, well, just stay here. So first, bring up the legend here. Right here in the lower right corner. And so we have our surface temperature and air temperature here. So if you notice, you can close that because it kind of. So it looks like here we have about the same temperature at both sites. Again, we have an even different aerial photograph here because notice that one of these. This is an older one. This monument is still under construction. So click on the Old Courtyard Northwest site first. Well, I guess. All right, so let's see. So our surface temperature, what was the surface temperature for that site? For this lane? What's it's on there.
22.1.
Okay, so now change that to current temperature or air temperature. So our air temperature is now. Oh, that's interesting. So in this case, well, it's not interesting. Well, it is interesting, but let's just keep that in mind. So in this case. The air temperature is actually higher than the surface temperature, right? So let's go look at the other side. Let's just close that box. And let's see. So for surface temperature here, what's our surface temperature here?
22.1.
Exact same temperature. So let's look at the air temperature. So the air temperature is 16 degrees Celsius. So, and if you notice in our graph, you can see, well, let's do something. Lane, hit that custom button on the bottom of the graph. Whoa. Zoom out a little bit, zoom out. Or just drag the map to the left, the whole map. There you go. Hit that custom button, please. It's right there at the bottom, right there. Custom. So we're gonna change the date range, change that to like 3/29. March 29th. Change that to 20, yeah, there you go. Hit plot. Okay, so now we just have the data for when we were out there. So notice it's about, so we have 16 degrees Celsius and then up to maybe a little bit warmer. So you can close that box. So Miss Lane, well, zoom in on our data, your data points there. Right there. Right. Okay, so click on the so the old courtyard lawn site. Click on that again. Let's look at that again. That was very curious how that came out. So I just want to make sure I saw this right. So the surface temperature was 22.1 degrees Celsius. And then bring up the air temperature again. Air temperature is 24 degrees Celsius. So given what we have discussed in terms of the urban heat island effect, what did you observe from those results in terms of the effect of surface temperature upon air temperature, perhaps? Excuse me. What did you learn about the effect of land cover upon temperature, based upon what you've seen observed here? Okay, let's break it down a little bit. Which of the two sites had the highest surface temperature?
Wasn't they the same?
Okay, so the surface temperature amazingly was exactly the same, but in the case of the well, this is unusual because on the grass we had an average air temperature that's actually higher than the surface temperature. Go back to the other site. Just kind of like really drill down into the data. So again, same surface temperature. Go back and look at the air temperature again. So the air temperature here was 16 degrees Celsius, right? So the concrete was 8 degrees Celsius cooler than the grass. Well, the air temperature near the area where the concrete was 8 degrees Celsius cooler than the grass, which would strike us as very unusual. That's just something. Okay, I'm gonna try something. Let me take over this for a second. Hold on. So we're going to re-examine. Do the same thing I did with the other groups and kind of do a deep dive. So we're all learning here, right? We're all learning here. Right, so don't worry, I'm not picking on anybody. I'm just curious. I'm just curious. So this is Lane's data, clouds. So we had that's Lane. This is the old courtyard northwest corner site. And that's 20 degrees Celsius, right? Right, Ms. Lane? It's 20 degrees Celsius. This is your sheet, right? And let's see, surface to conversion. Still 20 degrees Celsius there. And now we have to find the whole courtyard one. 19 degrees Celsius. So what we have to do is, we transfer our data from our printed sheets into the data entry system, We just have to be sure that, we're just careful in entering those data. And clearly, what might have happened was you probably saw this 19 and just thought it was 16. Put it in there. So it kind of threw off the data in the map. But that's nothing, hey, we all make mistakes, it's part of life, right? We're all here to learn, big deal. But you should always double check your data when you see something that appears to be off. And that's just part of doing science. And so when you're a teacher, you should just, one of the things about teaching science is you should tell children they should not be afraid to make mistakes, right? Don't be afraid to make mistakes, because that's something that some of the greatest discoveries in science were made by mistakes. Complete mistakes that people never intended on happening. Okay, so let's bring Miss Lane back up here. A couple more things we'll do. So just had a little, like I said, I'll put you back. Let's take one more look at your data. Scroll out a little bit. Zoom out, excuse me. So just stop right there. So you notice that all of these measurements were taken at the same time. Notice, were we over here? That's one of our, so some of you all use the Globe Observer app on your phone, right? And so now some of the data came out pretty close to where it was supposed to be, but notice some of the there's here one over here, there's one on top of Crouch Hall, there's one over here. And we know we weren't here, or there, right? So this really illustrates the error that is in the GPS receivers that's inside of your mobile devices. Remember I said they're off by about 300 feet? That shows it right there. Ms. Lane, where did you get your data from? What was the source of your latitude, longitude data? Where'd you get it from? People were outside. You had your students, right? One of your students reported the latitude, longitude to you. How'd they do that? Were they using the phone?
No,
What were they using?
the little temperature thing.
No, it was a GPS receiver. The Kestrometer got used. Yeah, so notice that using the GPS receiver, your points were spot on, right? Because you entered the data from the GPS receivers into the data visualization system, your points are spot on. So you have to be really careful if you're using the Globe Observer app to double check, perhaps even with Google Maps, where your points are, because the GPS receiver that's in here is very shaky in terms of accuracy. Okay, give Ms. Lane a hand. Our conservative speaker, thank you very much. Ms. Lane. Okay, just a couple more things and then we'll be out of here. So assignments for next week. FYI. So we'll finish up next week with reading assignment D. Oh, let me. Thank you, guests. So that concludes our GIS day Earth Week at Tennessee State University. Thank you for joining us, and until next year or next fall, we'll be